From toaster to thermoelectric battery, technological breakthrough to save the Earth. In 1919, American mechanic Charles Strite created an invention that would change everyday life, the automatic toaster. The innovation not only improved the eating experience, but also laid the foundation for a future full of technological possibilities. For millennia, many cultures had toasted bread over an open fire, a process that required intense concentration and often produced inconsistent results. But in the early 20th century, technology took a leap forward with the invention of nickel-chromium, a material that was both heat-resistant and durable. Nickel-chromium was not only a material advance, but also opened up a wide range of applications in thermoelectrics. When used as a filament for household appliances, the compound could withstand high temperatures and distribute heat evenly. In particular, for toasting bread, this compound ensures that each slice of bread is heated perfectly, completely eliminating the problem of scorching or uneven toasting. Charles Strite's invention not only meets the needs of modern life, but also changes global eating habits. The automatic toaster has become a symbol of convenience in the kitchen, helping users save time and effort. In particular, it opens a new era for household appliances using heat, creating conditions for many subsequent inventions to be born. If you want to add more details or expand on the idea, let me know. The turning point of baking technology. Nickel-chromium, when passed through an electric current, will generate large and stable heat, becoming an ideal material for devices that require high heat sources. One of the outstanding advantages of this compound is its flexibility, allowing it to be easily shaped into thin strips or coils that fit the standard size of a slice of bread. This allows heat to be evenly distributed across the bread's surface, ensuring that each slice is perfectly toasted without manual intervention. Charles Strite, with his talent and vision, not only took advantage of nickel-chromium, but also added important improvements to the design. One of them was the integration of an automatic timer, a revolutionary invention of that era. This timer helps control the toasting process, automatically turning off the heat when the bread reaches the desired doneness. At the same time, the mechanism to pop the bread after toasting not only increases convenience, but also ensures safety for the user, avoiding direct contact with hot parts. Strite's toaster was quickly recognized as a game changer, notably the appearance of sliced bread, a product created after the toaster to optimize the convenience that this device brings. Previously, bread was often sold whole, and slicing was the responsibility of the user. But when the toaster became popular, the demand for pre-sliced bread increased sharply, leading to the birth of industrial bread slicers. The combination of the toaster and sliced bread not only revolutionized the breakfast of millions of families, but also marked an important step in the development of the modern food industry. From bread to bricks, the untold story. Today, baking technology is no longer limited to bread. A more ambitious and important application has emerged: a giant industrial toaster. Instead of baking bread, the device is designed to bake bricks, rocks, and molten salt in an effort to solve one of humanity's biggest challenges: energy and pollution. Every year, industries around the world consume a huge amount of energy to generate heat to produce cement, steel, paper, food, and countless other products. This process accounts for 20% of total global energy consumption and contributes to 20% of annual carbon emissions. Much of this energy comes from burning fossil fuels, which cause serious pollution and exacerbate climate change. Giant toaster, sustainable energy solution. Modern industrial toaster technology has taken the basic principles of the toaster invented by Charles Strite in 1921 and applied them to a much larger scale with superior efficiency. Materials such as bricks, stones, and molten salts play an important role in storing thermal energy. Thanks to their cheapness, ease of availability, and high heat resistance. In these systems, nickel-chromium alloy nichrome heating rods are installed inside large bricks. These bricks are not ordinary bricks, but are specially molded with grooves or air channels to improve air circulation and optimize heat transfer. This design allows heat to be distributed evenly throughout the bricks, ensuring maximum efficiency. A typical thermal storage room, measuring 12x12 meters, can hold tons of bricks and has the capacity to store hundreds of megawatts of thermal energy. This is equivalent to the electricity demand of hundreds of homes over the course of a month. This makes industrial baking systems not only an efficient solution for food processing, but also an energy-saving method that meets modern sustainability criteria. This technology is not limited to the food industry, but has the potential to be used in many other industrial sectors where heat needs to be controlled and stored. Materials such as bricks and molten salt, combined with advanced heating elements, make the system a reliable solution for large energy requirements, high efficiency, and superior temperature. When the system is turned on, the heating elements heat the bricks to temperatures of up to 1809 C. The storage room is covered in insulated steel to minimize energy loss, with a loss rate of less than 1% per day. When energy is needed, air or compressed air is passed through channels in the brick, absorbing heat and reaching temperatures of 1700 C. The hot air can then be used to heat spaces, turn water into steam, or serve industrial processes that require high temperatures. These extremely high temperatures represent a huge step forward. Previously, achieving temperatures above 290 C without fossil fuels was a major technical and cost challenge. However, thermal batteries can store energy for long periods and release it quickly when needed, meeting the stringent requirements of the industry. Combining renewable energy. Another big advantage of thermal battery technology is the ability to integrate with renewable energy sources such as wind and solar. These are the cheapest sources of energy available today, but they are also unstable due to their dependence on weather conditions. By storing excess wind and solar power in thermal batteries, we can ensure a continuous supply of heat and power, even when there is no sun or wind. The future of industrial toasters. When companies switch to thermal batteries, they will save money and reduce their carbon footprint. The technology is twice as efficient as burning fossil fuels and costs half as much as grid electricity. The best part is that the system is ready for large-scale deployment, requiring only policies and financial incentives to promote the replacement of older technologies. Conclusion: from a compact kitchen appliance to a revolutionary industrial energy storage system, the toaster of the future has come further than Charles Strite could have imagined. By adopting this technology, we are not only toasting bread, but also toasting a sustainable future for the planet.